What are literal equations? You will come across literal equations in other maths topics and in science. These are the formulas that are used in different calculations. Examples, we have the volume of a rectangular prism V is equal to length times breadth times height. Another example, velocity V is equal to U plus AT, where U is initial velocity, A is the acceleration due to gravity, and T is time, and V is the final velocity. So in literal equations, you will be asked to change the subject of the formula. For example, if we look at the volume of a rectangular prism, you could be asked to write this formula in terms of H. Now, why is this important? Let us look at an example from geometry. We are given a rectangular prism and we are told that it has a volume of 90 cubic centimeters. Also given in the diagram is the length, which is equal to 6 centimeters, and the breadth, which is equal to 3 centimeters. The height is unknown. So given the information, you need to calculate the height h. We know that the formula for the volume of a rectangular prism is length times breadth times height. Here we have the information on the rectangular prism presented again. There are two ways that we can solve for h. In the first way, we substitute the information or the values that we've been given for volume, length and breadth into our formula. So we have 90 cubic centimeters is equal to 6 centimeters times 3 centimeters times h. Simplifying, 90 is equal to 18 times h. We solve for h. H is equal to 90 divided by 18, and the answer is 5 centimeters. In the second method, we can rewrite our formula in terms of h. So which means we divide both sides of our equation of our formula by L times B. So we have h is equal to V divided by L times B. Now next we input the values that we have for these variables using our calculator. In one step we can get our answer of 5 centimeters. This is a much more elegant way of doing our calculation, and it's less prone to error and to mistakes, as long as we've mastered the skill of manipulating the equation and rearranging the equation in terms of one of the other variables. Now let's look at a few examples. In the first example, we have V is equal to U plus AT, and we have to make A the subject of the formula. We take the U over to our left hand side, so we have V minus U is equal to AT. Remember, this is a linear equation, so we are solving for A. We have to apply the methodology that we've learned previously. We want to isolate A on one side of the equation. So we have AT on our left hand side, so we divide both sides by T, and we are left with A is equal to V minus U over T. You can see that I've swapped it around. You can swap the terms around as long as you keep them exactly the same. So I could have written it as V minus U over T is equal to A, but I've swapped it around in the answer because we're wanting to solve for A. In our next example, our formula is V is equal to pi r squared h, and this is the formula to work out the volume of a cylinder. We are asked to make r the subject of the formula. Take note that we have r squared. So we divide both sides by pi h to isolate r squared. So if r squared is equal to V over pi h, square root both sides of the equation, r is equal to the square root of V over pi h. Again, it simplifies things so that if we wanted to solve for r and if we were given values, we could have used the square root of V over pi h, input the values that we were given on our calculator, and get our answer in one step. In this example, we are asked to make G the subject of the formula, and we are given T is equal to 2 pi times the square root of x over G. Notice we have a square root and we have G in the denominator of a fraction. So the first thing is to get rid of the square root, and we do this by squaring both sides of the equation. So on the left hand side we have T squared, on our right hand side 2 squared is 4, pi squared is pi squared, square root